2 years ago, as many other people here in Europe, I rushed to purchase a solar system for my house, only to discover that it seems that everybody had the same idea and the installers were overwhelmed and had a backlog longer than 1 year to deliver. So eventually I decided to do everything myself, not without some setbacks and unexpected problems. So it is after this experience that I thought to share with you what I've learned in these two parts presentation. Today we will see how solar systems are made, so you will get an idea of what's best for you. Next we will go deep, understanding how solar inverters work and some potential side effects. So with no more ado, let's get started. First off, an overview of the typical topologies that are used for systems that are installed on houses, not for industrial buildings or large installations, because that goes beyond the scope of this presentation. So the essential topologies are off-grid, on-grid, hybrid and UPS. As the name implies, off-grid means you are on your own, you are not served by the utility grid. When the sun shines, you use the energy from the cosmos, and when the sun sets, you use the energy that you have hopefully stored in the battery during the daytime. On-grid, on the opposite side, is that you rely on the energy that comes from the utility grid, and you provide energy, you pump up energy to the utility grid when the sun shines, and that's essentially an exchange. Then we have the hybrid, which is kind of a combination of the previous two topologies. You still use the energy from the grid, but when the sun shines, you use the energy from the cosmos, and when the sun sets, hopefully you have stored enough energy into the batteries and use the energy stored into the batteries to power your house, maybe for the first hours of the evening, and eventually, if not enough, you draw energy from the grid. Then we have the UPS topology. The UPS is more akin with the off-grid solution. You are essentially off-grid when the sun shines, and if you have stored enough energy into your batteries, and if something goes wrong, if you have not enough energy in your batteries, well, in that case you can still draw energy from the utility grid. What to choose from is really up to you and your situation and your needs. I've chosen the UPS topology as it is faster to set up because it doesn't require to send a communication / agreement with the dispatcher of electricity, but this depends by the local regulations, so I recommend you to check them before. Inverter and panels configurations. The first one is the individual inverter, which offers the best maximum power point, which is not the Microsoft application, but it is the maximum point of power you can draw from the panels. And okay, this requires a little bit of explanation, so let's dive in. So when a photon hits the surface of the cell, it excites the electron that goes from the valence band to the conduction band, and the same happens on the opposite side of the junction with the holes. And so the electron here can move and go out of the cell and go through the external circuit and produce useful work and recombine back with the hole on the other side of the junction. However, over time, if this electron can go out and produce useful energy, the energy is lost because the electron goes back to the valence band, and the energy is lost, dissipated through heat. That said, we have also internal resistance, both shunt and series resistance, that influence the power we can get out of the cell. So if we have lower shunt resistance or higher series resistance, we lost power through this through these resistances, and these resistances not only resides inside the cell but also inside the structure, the conductors of the panel, the diodes used to protect the panels or to exploit the better performances from the panel, and altogether contribute to the efficiency of the panel. So the maximum power point is different from the theoretical maximum power that the cell could output, which is the maximum open circuit voltage times the maximum short circuit current. So this ratio, the maximum power point over the maximum voltage, open circuit voltage, and the maximum short circuit current gives the fill factor that usually is around 80%, 85%. My solar panels, for instance, have about 84%, more or less. So we need to catch the maximum power point that moves and changes even with the solar irradiations. So we need some kind of circuit, some kind of solution, external solution, to get the maximum out from the solar panel. So let's get back to the inverter and panels configurations to see, to consider this and other factors. So we've seen the individual inverter characteristic. It has a higher cost and a trade-off between maximum power point and the overall lower efficiency, because each inverter, of course, has some efficiency, and this is a factor that must be computed. Then we have the branch inverter, where each inverter is connected to an array of solar panels, so giving a good maximum power point. It is quite expensive, has a slightly lower efficiency than the central configuration, but is better than the previous one. It is best suited for large arrays of solar panels. Then we have the central inverter single string, which is one of the most common configurations, where we have a string of solar panels connected in series, and those are connected to the inverter, to a single inverter. We have a good maximum power point. It is cheap, and it is best suited for, of course, single array of panels. Then we have the central inverter multiple maximum power point, which is a kind of compromise between the previous two. It is a single inverter that has two inputs for two different areas of solar panels with two different maximum power point tracking circuits, and it is a little bit more expensive, but it's best suited for 2 to 3 areas of solar panels. And finally, we have the central inverter with parallel diodes to connect together different areas of solar panel. Okay, this is the worst maximum power point. However, it is the cheapest solution, and for the discussion that follows, we will consider the central inverter with the single string, which is the most common and simpler solution. So what a solar system is made of. For the sake of completeness, we will look at the hybrid solar installation that comprises all the possible combinations. So we have the string of solar panels, then we have the surge protection discharges, essentially, that protects from EMPs and lightnings. Then we have, of course, the inverter, the batteries and a battery breaker and fuses. Then we have the meter that connects our house to the utility grid, and this meter must be bidirectional if the hybrid provides energy back to the grid. But if we have a UPS, we just don't need to change this. It is enough to have a normal meter. And then we have the magnetothermal breaker from the input of the grid, magnetothermal breaker and RCD to our household appliances, the output of the inverter. So this is the full configuration. So you have a map of how the system works. With this, we have reached the conclusion of today's presentation. Next, we will go deep inside this typical solar inverter to understand how it works and some potential side effects that might upset you. So don't forget to subscribe and hit the bell icon so that you will be notified when next video will be up. Also, hit the like button because this helps the channel to grow and it doesn't cost anything to you. Thank you very much. Also, in my website at accidentalscience.com you can find complementary information and more. For today, that's all, folks. Thanks for watching. See you next time. Bye. And as I mentioned in the introduction, I had to do all the work myself because at the time when I asked some electricians, they gave me a long time to deliver the work because they were overwhelmed. So I decided to do everything myself. I bought the inverter, I bought the solar panels, the last one that were available in the warehouse. Finally, I discovered that the hardware that was needed to hold the panels on the roof was not available anymore. I've taken the design of the brackets and asked to a local company to cut the stainless steel to measure and bend the stainless steel to measure, and made the brackets and the plates on myself, even because in my roof it's not possible to drill across the roof, so I had to glue the parts on the roof. So it was a new technique that however I've seen other already used, and I used the same bonding component used by them to glue the plates on the roof. Hopefully it will last for a long time.
Ooh.